Welcome to our 341 project by Joe Calrackle and Oliver Panasowicz. We'll be going over R programming language, and it's basically used for stats, graphs, stats mainly. It's very functional, like F sharp uses a lot of higher order functions, and that's basically your key here is to use those. So we'll get started right away. Here we have some basics assigning variables. Three ways you can do it: equal signs, the arrows like in C++, or you can use the assign function and you give it a variable name parameter and whatever you want to assign it to. You can also do multiple assignments, so you can send the value of B to C to D, and yeah, and here we're gonna test it. So we have A plus D, and D should have the value of 20, and A should have the value of 10. So here on the bottom we get 30, and 100 minus 10, 90, so it works. There's also a remove assignment, and it just basically removes the value. Not really good use for it. You can get the type because it's type inferencing. You can also get type by using the class function. And here we're getting the class of B, and it says numeric. There's a date data type, and to use it, basically you would do as date function and then give it a string date. The second one here is not a date, that is just a string. Here, if we check the class of both of them, we get one is a date, the other is a character. So you want to use the add as a date function. How do we write functions in R? Um, you would just give it a name, use this function keyword syntax here, whatever parameter you want, and then the body. So here we're summing whatever the parameters, we're adding 3 to it. We're assigning the value of 10 to x. We pass x in, and then y should come out as 13, and it does when we print it right here. So that's how you do functions. Loop, pretty much like the loops we did in C# with SQL. So we give x a value of 0. We have, and it prints out 0. Have a for loop, x in, give it a lower bound, upper bound, with a semicolon or colon in the middle, and then all we're doing inside this loop is just adding 1, and then we're printing out x again, and we see here we get 10, so it adds 1 each time, so we get 10. Next we'll cover vectors. Quick shortcut is just Control L to clear the console, and it's kind of like SQL, you want to highlight and run it. So the vectors are similar to C++ vectors. This is how you assign it. You need the C function. I don't know the purpose of that, but you need the C. Here we can also do it with dates. Some operations we can do is we can multiply the whole vector by 2 or any number, multiply divide, and it'll do it to every single element. So here we multiply by 2. You can see all the elements get multiplied by 2. Shortcut for assigning values is we can do upper bound, lower bound, and it will populate the vector with those numbers. So here we have vectors that are populated with that. We can do vector to vector operation. A condition on that is the vector size has to be the same for both vectors. So here we're adding 2 vectors together, and the vectors contain numbers 1 through 10, both of them. So it's basically just doubling values from 1 through 10. And if we look down here, we have the values doubled, so it did add the vectors properly. You can also run logical operators across the elements. So this is checking if there's an element less than 10 in vector 5, and you can see the first 4 are. So it says true, 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 false, false, false. How do we get the index? Basic indexing like arrays, or you can give it an upper and lower bound. It'll give you values in that range. If you do operations with an invalid length, you'll get some faulty values like 11. That shouldn't be there. That should be 20, because once it gets to the smaller one, it'll go back to the beginning and add it again from there, and we don't want that. Continuing off, we have frames. which is basically like the SQL data sets we create. So this is very useful. Here I created 3 vectors, one with ID numbers from 1 to 5, random set of ages, and names based on Mario and Slenderman. Um, this is how we would create a data with the data.frame function, and you would just give it the columns. And here we have the data right down here. Getting data is the biggest and best way is just using whatever the table name is, $, and then whatever column you want. So here we want the age, and it prints out all the ages. Also, we can just specify the row, so table 2, or this column, my bad. So here, by giving it a single element, we get the second column, which is age. Or we can do a column or a row column. So this gets us row 3, column 3, which is name Slenderman. So because that's the third row, third object. Here we have second row, and here we're getting the columns 1 through 3. So we get all the information on Luigi here. Or you can just leave the second blank and you get the whole row information. Well, basically the whole column. That's how we do frames. And lastly, we have the main way it's used. A lot of these higher orders are in the packages you can download with these, and there's a ton of them, and each do a lot of different data stuff. So I'm using one called ggplot2, and it's basically like color plotting, which we have here. It comes with a pre-built data called diamonds, which give you like cut, color, price, stuff like that for different diamonds. And so here we have the data for that. Head and tail, higher order functions. Head returns like the first 6, and tail returns the last 6 in the data. It's huge data, so we don't want to show everything. This is a shortcut for that. Here we're going to be creating a scatter plot, and the higher order function to do that is just called qplot. And then the 2 rows or 2 columns we want to specify here is the caret in the diamonds, so $caret, and then the price, so $price from the diamonds data set, specifying the data set, and then coloring based on whatever the clarity is. And then we just run it, and then here we see it ran properly, and then here's the graphic created on the side with the price. As price increases and caret increases, you can see how that works. And then coloring, I'm not sure what that data really represents, but that's just there. You can do other things like histograms using the hist higher order function, or scatter, or you can create a scatter plot using plot. This is like qplot is a little bit more advanced. So